Good evening.
Hi, 𝐬𝐻.
Hello, Christopher. Let's wait a little bit for our guests to start the webinar. The webinar about MSA and SPC, finally, which is the second webinar in the row of the Robust Quality on the shop floor webinar series. Let's wait a little bit for our listeners, because as usually, there will be a lot of people from around the world joining us to this important topic, I would say, because SPC and MSA, as two of the core tools, are always causing a lot of troubles and questions. So let's wait a little bit. In the meanwhile, we would like to ask the people who are joining us to write from their names and from where are you from. Maybe what are you doing for quality in your organizations? It would be nice to hear about yourself.
Yeah, let's say some of you aren't necessarily quality professionals, but you want to learn more about the quality process and what do these acronyms mean, on how do I make my processes or my role be more involved with quality, whether we can have a better quality culture, how can I appreciate the quality process better and the responsibilities with it.
Okay, let's see who we have. Oh, we have already the people who were also with us on the first webinar, so I can recognize some of you. Yes, okay. So we see a lot of people from YouTube are joining, because tonight we are in YouTube, LinkedIn, and Facebook. So we are very glad that you are showing up, more and more of you. For the people who are anonymous, like LinkedIn user, you need to write down your name also and the surname, because later it will be important, especially if you'd like to get the certificate of attendance, about which I will say in a second. We have Anya with us. Hello, Anya. We have Jean. Again, LinkedIn Jacek is with us. Oh, 𝐿𝐻𝐿, Maria. Maria, write your surname as well. Eric from Belgium. Okay, so we have Poland, Belgium. There was UK. We have again Poland. Who else is with us? Coventry. So this is UK again. Yes, you're joining and joining. Great. We have also Morocco. So we are going international, really, again. Tunisia. Pavel from Poland. Oh, we have Sweden. Hello, Sweden. And yes, there are a lot. Germany. Mexico. We have Mexico. Good afternoon. Yes, me and Christopher, we are located in Europe, so I'm close to Warsaw. Christopher is in Glasgow, and tonight we are for you. Okay, so you can leave slowly your names on the chat, and let us maybe slowly approach the topic for tonight, which we prepared for you. So I think this is the right moment to start, Chris. Don't you think so?
I agree. And I'd just like to, before we really start kick off today, I'd like to say I really appreciate the involvement of everyone wanting to join this. It is a technical subject. It's not something we can obviously go in huge detail tonight, but I'm sure by the end of it, you'll have a better understanding at a foundational level. And this is the objective. We're going to go through some key changes. You know, it's a learned journey. So really appreciate the involvement. It's quite a difficult, but also challenging and rewarding topic once you know how to do it.
Okay, so let's start. At the very beginning, let me introduce QualityWise to the people who are for the first time with us, because QualityWise is specializing in quality management, quality assurance in automotive industry, and how we can support our customers. We are specializing in the quality training, quality associated topics, also workshops or coaching or facilitating, like for instance, FMEA analysis. Auditing according to IATF, to ISO 9001, of course, for the German market, VDA 6.3, 6.8, CQI audits. What's more? And also we're helping you on the daily job with the consulting with any topics which are relevant to you, how even to strengthen your quality culture in the organizations. If you'd like to learn more about QualityWise, we invite you to visit qualitywise.pl to see how we can support your organizations. And tonight, we are launching actually the second webinar from our 5-webinar series about robust quality on the shop floor. The aim of these webinars is to be designed as one big picture, how this quality on the shop floor can be assured to say that this is a robust quality. Last time, 1 month ago, we have been talking about daily production readiness. So how to start, actually how to launch everyday production, every batch. And today we will be talking about SPC and MSA in the production reality. So I think it will be quite interesting because, let's be frank, these are really demanding portals and they are requiring specific knowledge. This is certain knowledge. You can't, without having this knowledge, you will not be able to work with SPC and MSA, okay? Also, let me at this moment tell you that for the people who are registered for our webinars, and who participated at least 4 times in these webinars, we will issue a certificate of attendance. If you registered, but you haven't been, but today you still have the chance to be 4 times with us, we will also share with you additional materials like this presentation and also the guidelines or the checklists. Like last time, we prepared a checklist for daily production readiness, and this will be exclusively sent to your mailbox. So we invite you to register if you still didn't do it by scanning this QR code on the left top corner. Okay, so I hope this is the beginning, the introduction to our webinar series. And now let us maybe present ourselves before we'll jump into the topic. So my name is Agata Lewkowska. I'm the founder of QualityWise and also quality management system specialist. I specialize mostly in quality management system because I really love working with IETF and system-wise perspective, because actually system is covering all the aspects of quality. So it's quite a broad approach, which actually satisfies me. So you can rely on me today in terms of IETF. Core tools are also important to me because as an auditor, I need to know them. But let's maybe listen a little bit about Christopher, because Christopher is also specializing in core tools. Chris, present yourself, please.
Yeah, so hi everyone. I've introduced myself briefly, but I'm a quality assurance engineering expert. I've held positions like many of you throughout the ranks and developed and grown throughout the industry. I hold a position as well as part of QualityWise outside of that as an OEM. I'm a head of supplier quality in the automotive industry, and I've worked for multiple OEMs, not just as a supplier. So I've been a tier 1 supplier, and I've also been the customer, which I am also this position. I specialize in EPQP and PPAP. You know, I lean more towards that side of it, not towards the VDA. The VDA is very good in some areas, very strict, very, very rigid, very, objective based. And I also manage problem solving and crisis management. So these are things like when things go wrong, when a tool goes bang, or there's a force majeure. I've been very exposed to those sort of scenarios in my career and continue to be. That's fairly normal within my role. I'm also a master trainer in something called training with industry. This is how to teach the trainer, how to train the trainer, and how to do that from a master perspective. So I've got more than 17 years experience in the automotive industry, and it's a pleasure to present this to you tonight.
Okay, thank you, Christopher. One thought also came on my mind because I saw on the chat we have some anonymous people. If any one of you would like to receive later a certificate of attendance, you need to write your name and the surname, okay, on the chat. Please remember about this, because otherwise it will be difficult for us to recognize you after this webinar. Okay, so let's start. Guys, As you remember, in our webinars, we love asking questions. So let's start from the very beginning. The first question: how you understand preventing defects in terms of monitoring? We're quite curious. How is your understanding of this? Also, let me just tell you that we'll be waiting for your answers on the chat. Take this opportunity. And please also bear in mind that we will have like 10 seconds shift between the different platforms and in the streaming. So let us wait a little bit for your answers, and we will reveal interesting comments from your side. But in the meanwhile, Chris.
Sorry, Agatha, I'll keep the conversation going because there's a little bit of a pause and I don't want people to feel like this awkward silence. So maybe some hints without giving you the answer. What does it mean? So if I rephrase it, because for some of the non-native speakers, what does it mean? Because it's a bit of an obscure question. What type of monitoring, good monitoring, should prevent defects? What does good look like in your opinion? You know, I'm not going to give you too many hints about that, because you might say, oh, having a really good manufacturing execution system should be the way, and so on. Automation, AI, maybe that is a genuine answer, but what does good look like is the question. That's what that means. How do you use monitoring and measuring to prevent a defect? And some of you might not even do that. Some of you might not even do any monitoring or measuring. Maybe that's a way to address it as well.
I see the first answer. Jean wrote us, react before having NOK parts, always. Good. Good answer. Any other ideas? Let's wait still.
It's a good foundational message about reacting before. It's about trying to be proactive. Maybe more of a hint is about not being reactive and being predictive. Can you predict? Is another one?
We have, yes, use of control charts. Yes, can be. Understand the behavior of the process and the moment where we will have defect. Oh, yes, the behavior of the process. I like this statement. Patrick, statistical process control with proper control limits. Yes, definitely. They are not taken just like that. They must be calculated. Error-proof karaoke. Okay. What else? Proactive monitoring, spotting trends before the problem develops. Oh, keyword, trends. Capability, control charts. Yes. Stefan, online 100% SPC. 100% SPC. There is a little bit mismatch in these statements. However, I think I understand you. But 100% either or, statistical process control, I would say. Regards from Shuni. Okay, this is Emma. Okay, so we have also the answer: real-time machine monitoring, SPC in processing inspection, kappa. And let's maybe display this one: detect drifts of my stability. Okay, Chris, do you want to comment, or are we going further?
Let's move further, and it's going to elaborate on that on the next slide. So what does it mean? So we're going to go through this one by one, and it means detecting instability before non-conformity. So some of you have mentioned stable,
yes,
stability. We're trying to see trends. We're trying to see drifts before things are wrong. It's too late before you get to the limit. That's the point. We want to distinguish noise from the signal. So this means that random variation, we don't want things which is causing us not to trust the system in the monitoring system of the actual process.
It was not said. It was not said about the noises.
It protects the customer before shipment. So it doesn't just protect you as a supplier. It means that you are ensuring that every product that is delivered is not going to cause a defect or cause a problem. Either that's geometrically, might be cosmetically, it depends on which method. But the point is, your product has to be within the limits agreed with the customer.
Yes.
Let's move on to the next one. So it supports decision making in real time. So, I like to use this phrase quite a lot in my career, which is, if you don't come to the table with facts and data, it's just an opinion. An opinion doesn't mean anything. You might say experience, but experience can cause bias. The point is, what does the process tell us? What is the trend? So, and then when does it fail to prevent defects? Now, this isn't a question to the audience. You can think about it and pause about it when it goes to this point on the slide. But I'm going to move on to the next slide and explain and answer it rather than get you to answer it. So it calculates capability on unstable processes. So if you don't have a stable process, your calculation of capability is not true. It's not truthful. It's an unrealistic measurement, and it's not going to tell you its potential. It's a false reading. What would be the next point?
Waste of time. Yes,
yeah, you're wasting your time.
Simply.
It's putting your finger in the air and saying, I think it's good. That's the same thing, really. Let's talk about the next one. Performing a measurement systems analysis. So for those who might work for McLaren, that terminology doesn't mean MSA, it means manufacturing site assessment. AIAG doesn't say that. So in the context of today, it's a measurement systems analysis. And it means you only do it because the customer is going to turn up, or you're only going to do it because you want to comply with 9001 or IATF or any other quality standards. You only do it upon request. That's the point. Really, you should do it whenever there's a change, whenever there's a risk in your process. Let's look at the next one.
Yes.
Or if you want to add to that, Agatha.
I would add only this, that you should pay attention to the rules for MSA defined in your organization. Because if you are defining the time frame when you need to do MSA, or the circumstances like deterioration of the measuring devices, these are the certain criteria even for the audit, which will be verified, yes, but pay attention to tight time frames, because if you have a lot of measuring devices, it might be difficult to conduct MSI on all of them. But also there would be a question, okay, what about the calibration and the time frame from calibration? But this is a different topic, but a little bit connected to MSA, because in many organizations when I'm auditing, I hear we have calibration, yes, so we are covered in terms of MSA, but this is completely different topic and it shouldn't be mixed, okay?
Yeah, and I can say that from a customer. I hear that a lot. I've heard that a lot of my career, where they say it's calibrated, it's not a problem. That's not what that means. What are you using the device for? What product or process are you trying to measure with the device is the point. MSA is not just the instrument. It's not just the instrument. It's how it's used.
Okay.
So the next point is react only after defect detection. So that was raised, so if you react only when there's a problem, your monitoring is failing. It's not doing its job. It's not doing its intent. So that's the point. The key message is that this leads to a reactive approach. How many of us firefight? How many of us only deal with it after the problem? How many times do you do it when the customer's complained, or there's a recall, or there's a serious failure of prevention? MSA and SPC's intent is to be proactive. That's the point of doing it. We're trying to predict. We're trying to trust the system. We're trying to trust how we measure and monitor. That's why we do it. Yes,
this is not another core tool. There is a logic why it is in those core tools as very important tools for the even automotive industry. Yes. Okay, this is a good question.
So my perspective, why do customers escalate? Why do we as a customer escalate? It's because you declare the process is stable with no facts and data. I've used that earlier. You're saying it's stable, but there's no evidence to support that statement. The next point is that you said the measurement system is capable because you've done a fake 𝐶𝐵 calculation, but that's not the reality, because it's based on a foundation of instability, and it gives you the wrong reading. And let's look at the next point. The submitted inspection report, or some of you might know what this acronym is, which means initial sample or samples inspection report, or a first article inspection report to the customer, said the part meets the specification. Okay, but if you're using a device which is not trustworthy, the MSA is not trustworthy, then it's saying something is in specification when it's actually not. It's not the true value, is the point. And the key message is that complaints happen, field failures. These are things in warranty, in service. We've got some really good guests tonight in the chat who really know about field failure analysis, especially from the VDA perspective. This happens because of things like measurement systems not being verified and being stable, processes not being stable. So we're connecting the dots between all the different phases in APQP to get to the point of why this needs to be done. So field failures appear and capability drops. It suddenly drops and we don't trust the system. We don't believe in the system that comes from the supply chain.
Exactly. So let's talk a little bit about today's reality in the automotive, yes? Let me maybe take this one. Definitely you need to pay attention to this, that the customer are coming to us for the audit because there is a certain aim for this. Yes, they need to have this confidence that we are meeting the requirements. Yes, we can declare them. We are meeting the requirements, but the audit is independent. Yes, so the customer, of course, is protecting himself by verifying this, and this audits sometimes are very painful. Yes, if this is, for instance, VDA 6.3 audit, or recently happening VDA 6.8 audits. This may be very painful, yes, or other customer specific, yes, audits. But this is the reality. Risk-based thinking. This is very connected also why we have this audits, not only from the customer perspective, but also internally. Yeah, so the risk-based thinking is very present in automotive industry. On every corner in IT, we have risk-based thinking set straight. If we are taking into consideration the risks, did we prevent the risks? And escalations for statistical misuse if this happens, but also more pressure on reaction times. Yes, problem solving here will have a big role for this. And let's remember that due to the fact that state of the art is changing in our industry, in the automotive, also some manuals are changing, and now currently we are facing the SPC methodology as the combined approach of AIAG and VDA. Yes, and still under revision. Yes, so we still can give our input. So in the autumn, now we may expect closing time frame for this for this inputs, and later expect publication after revision this inputs. Yes. Okay, Chris, what about customer care about?
Yeah, what do they care about? So if we talk about the first point, I could say no surprises. They don't want to be shocked. And I've said this in other webinars, and I say this in our podcast, is that customers pay for the product to be the quality assurance level, 0 defects agreed by the drawing or the specification. It doesn't mean you can't have deviations to an agreed one. They don't want to be surprised. They don't want to wake up going, there's a problem. Okay, now I need to send my SQE to try and solve it for you. That's not the point. We don't want any field failures, which is a magnitude of 10. It's worse when it gets to the in service, in the dealership, when it comes to its MOT or its checks. It's far worse when it gets to that stage because it could be a recall at some point. And what else do they care about? No late containment. They don't want you to get to the D3 stage when we're looking at 8D disciplines methodology. They want you to contain it on time, if that's within 48 hours or 24 hours. Contain it. Stop the problem, stop at that source, and then find your permanent corrective action. So many organizations in the supply chain and OEMs, to be fair, I can reflect and say OEMs are like this as well, confuse reporting with prevention. I've got a report, I've got a KPI, I've got a slide deck, I use Power BI, but that isn't preventing the problem. It's not stopping the problem. It's just a status on a slide.
Yeah, exactly. Okay, so now let us show you our approach, how we, in quality-wise, we are facing the problems, the perspective of this robust quality in terms of preventing the defects in terms of SPC and MSA. First of all, I would suggest to think about the risk-based thinking. Yes, so what risk does this process create for my customer? And this is really a good approach because, first of all, it is also protecting yourself in the organization. Okay, is my measurement system trustworthy? Okay, I can't have reliable data if my measurement system is not proven. Okay, is my process statistically understood? Do I know what is happening in my process? What will I do when instability appears? And this is now the reaction, yes? And we think that if you are covering all these 4 elements, you will have this confidence that you won't work on the wrong data, okay? And you will take right decisions about your processes. So SPC and MSA, in fact, must answer all these 4 elements. Yes, I think 3 elements, sorry, not 4.
Yeah, three elements, but there's always more questions you can ask. So another way to view this is, because there's lots of buzzwords and there's different ways to do it, think about the risks, analyze the risks, and what are you going to do about it? Are you going to change something? Are you going to verify? Very similar to the PDSA or sort of wheel of thinking. It's just a way to break it down simply to say, how do we assess the risk and what are we going to do about it?
Okay, so let's ask another question to our guests. Now, this is really a basic and extremely important, and actually this is the beginning of the discussion. What shall be done first, SPC or MSA? How do you think?
Very, very interesting. Unfortunately, we can't really give any hints. It's a pretty straightforward question.
Yes.
What do you think? Gives a consensus, gives a viewpoint of what people think, and maybe this is why you've joined tonight or today, depending on where you are, why you're here, because of maybe a misconception. But we'll not give too much away. Let's see what the chat says. Hopefully not too many of you are jumping on Google and quickly checking, but let's see.
MSA second time. MSA first. Okay. Is there anyone else who would like to say SPC? Tough question.
We've got over 100 people tonight between different platforms. I'm sure someone's thinking,
yeah,
I don't want to say
MSA.
Yeah.
MSA, because we need to evaluate our system first. Okay, and I think this is summarizing this what is the idea. Of course, there's only one good direction and one answer in this. Of course, MSA. Yes, MSA is the beginning of the story. I hope everyone is convinced also that these both core tools must cooperate and they are working together. You can't talk about SPC. Of course, you could talk. You can work even with SPC without thinking about MSA. But at some moment of time, you should have MSA done to have later the data for SPC. Yes, so I'm very happy that we had only the right answers on the chat. Okay, I love the statement. Let's keep going, Chris.
Yeah, so we passed the gauge RNR, so the gauge repeatability and reproducibility, it's less than 10%, so we're safe. The study tells me that we're okay. So, dear customer, why are you asking this? Why are you probing deeper? Why do you think there's a problem? And I've worked with suppliers that have had a good gauge RNR result, but actually the measurement system was not trustworthy. So let's move on to the next point.
Yeah.
You have a measurement error. That's the point number one. Yeah, something is not trustworthy. You have a false stability. It's saying you're stable when you're not, because there is a margin of error. So you can't detect the drift of the error. A false capability, we've mentioned it earlier, that your CPCPK is really good. And then eventually, if you're working on PPPK, it's really good because the first two are wrong. If the first two are wrong, you're obviously going to get a false capability index. What's next? Well, you're going to get the wrong decisions. We're going to say, ship the part. It's fine. Argue with the customer. Tell them they're wrong. Tell them that they're not measuring it correctly. What is this called? It's called the propagation effect. You start from one small thing, and in the end, you have a significant impact on your customer or your business. You have to get all of these 4 things correct at each stage in this process. What is the key point, really, I could say? Well, the key point is that if your measurement system is wrong, you've said it in the chat, really good comments. I'm really proud that you said that. Your SPC is meaningless. It means nothing.
Okay. So another question maybe. What are the types of MSA? Maybe types is too much said, but maybe recommended practices which are working for the whole picture of the MSA. Yes. Yes. So
Yeah, let's see. I'm interested to
let's
see
see.
who
Yes.
who in the chat works on gauge RNR studies, or you do different versions, or what are the things to consider when you're doing this. Again, just like the SPC element about stability, there's more than one variable or characteristic that can influence the MSA study. That's the message. So let's see what people think. You know, I've lived and breathed MSA in my career, learning from an inspector level all the way to a lead engineer. And it's difficult because you might think that what you've done is correct, but from the customer perspective, it doesn't match how it's fit on the vehicle. It doesn't have correlation. We can't check the measurement, and it could be one of these things that is causing the problem.
Yes, I think metrologists here could have more to say. Yes, we have ANOVA and reproducibility and repeatability, and the first answer. Oh, now I like it. Bias linearity, stability studies. And what's more? Consistency. Okay. We have type 1 𝐜𝐸, yes. Our average range method. So in other words, we can say gauge RNR, many people are calling it like that, but this is called also average range method, according to the book, I would say. What else? Bias linearity and stability. Great. So we're closer and closer, yes. Because there was also repeatability, reproducibility. Okay, so it also showing that many of you are treating MSA also with a wider perspective, yes? Because, of course, we need to know why we have linearity studies. What is bias for, yes? And stability. Mostly, we're concentrating on the gauge RNR, yes? Yeah. So type 2 or type 3 MSA. Type 1 sometimes is for fast evaluation. Okay, so let's say about this a little bit, Chris, okay?
Yeah, let's talk about the elements. So for those who don't know what bias is, you might hear like an unconscious bias, which is not the same thing, but essentially what that's saying is that a bias, when you have a nominal true value, there is an offset to that. So if I have a gauge, let's say it's a headlamp gauge, for example, and it measures a gap, that gap should be 3 millimeters nominal, but the actual gauge surface is different from the nominal. That is a bias. It's an offset in the gauge by design. When it was cut, when it was manufactured, it's not perfect. There is a tolerance. There is a tolerance even on a gauge.
This can also indicate that you have systemic error in your measurement system. And mostly in these cases, people are doing adjustments, which is not allowed in according to even ISO 9001, yes. Because later you need to calibrate your device. Linearity.
Yeah, so linearity is a little bit different. It's not a parallel offset. Essentially, is a really good way of explaining this. If I took a vernier caliper and I measure it and I open the jaws to 10 millimeters, and I get a really good sort of correlation and accuracy and resolution, and it says it's within the expected range. But if I open that caliper up to the extended range near the end of it, and the correlation is bigger, the error is bigger, then it's not a parallel deviation. You start and you get this big sort of triangular effect where it's opening up. Linearity is essentially something called a sign error. If you think about your trigonometry, it's not parallel, it's getting worse. It's getting worse and worse and worse over a certain range. That's the point of linearity. You need to be very careful of this. Stability, it's already been mentioned, but what is the definition of a stable process or a system is where that all the variables are known, they're all confirmed, they're all controlled, and all the parameters are set. You don't constantly change, you don't constantly adjust, you don't keep recalibrating the device all the time. Otherwise, it's unstable.
This can be also used for calibration in time interval. Yeah, so important to know.
It's based over time.
Yes.
Repeatability. It's different. So repeatability, if you're talking about one appraiser or one operator in another speak, is only doing the thing. And if it needs to be measured by someone else on different shifts, this is when we might move on to the topic. Typically, a type 1 device like a vernier caliper is known. It's manufactured and it's hundreds, thousands, millions, and you can use a type 1 study. When you're using more advanced things for geometries, you need to look into reproducibility, meaning if I take this device, this component, and I put it onto the gauge, this checking fixture, every time I put it on, is it repeatable by the person in the measurement? And then the next person who puts it on, do they get the same result within a certain deviation or delta? That's the point. That's called reproducibility. It also matters for the customer. So I worked very closely in Nissan with one of our key suppliers where they made headlamps, and I like to use this as an example. They had a checking fixture, I had a checking fixture, and we couldn't reproduce between each other. So, there's something in the gauges or the measurement method is different, and it took a long time to figure out what was causing that. Moving on.
Oh, sorry.
One back. Attribute agreement. So this means, are we getting the appraiser agreement? Another way of saying, do we agree between appraisers, or is there someone who is the outlier? So it's not just about the physicality or the science behind it. Are you getting agreement between the different appraisers or not? Because that could be, yeah. Sorry, Agatha. It could be that because someone is more sensitive, or they have a training issue, or they don't know how to use it. But as you wanted to add,
yes, or someone is taller simply and can read differently.
Yes, I've seen that. Really key about your
mistake. This is
when you talk about where does that come into play? I'll give you an example because you might be thinking, well, that's a bit random. When you design a gauge for your customer and they pay for the gauge, typically they'll have an asset budget or a vendor tooling budget and they own the gauge. Why would that matter? When you design a gauge, you need to think about workability or efficiency. If it's difficult to use, it can influence the measurement, and it can cause a bias or it can cause an error.
Okay.
So hopefully that's a good example that people understand, but let's talk about the next thing.
Yeah. And no one said about this.
No one mentioned this. So if you work very closely with, ISO 17025, you probably know it a lot better than I do, but I've worked quite closely with that. If you're a metrologist anyway.
Yes, metrologist, definitely.
Yeah, absolutely. Subject matter expert, definitely. Yes. I've worked in metrology labs, but not ran them for a long time. Uncertainty, right? I'm not going to get into the physics of it or the science, but there is something called the uncertainty principle. And if you think about it, even when you get to an atomic level, and there's some animations that you can see on YouTube, if you have something moving in scale, getting smaller and smaller and smaller, you half the value every time, and you can never reach zero. It's infinite. And it goes all the way down to atomic level. You get to a point where you cannot measure the position of an electron versus observing. So it's the science behind it. And, the physicists who study this in university, that this is where it comes from. You can never know the exact true value, only within a certain degree of confidence. Statistically, that's what that means.
Let me also add here that in ITF, we don't have the requirement for the laboratories to be certified according to ISO 17025. But if your internal laboratory is certified according to this standard, then you're meeting more requirements than ITF is requiring. Yes, so it's more beneficial even for you. Yes. Also, let me emphasize that in AIAG MSA, you won't find uncertainty. Uncertainty is present according to German approach. So I'm talking now about VDA 5, according to VDA QMC organization. Yes. Yeah. Interesting if you like metrology.
So this is the key point when we talk about safety characteristics, CCs. You might have a different, designation in your company if you work in the German market. If you work with, VDA and you work with people like Daimler, it's different. But essentially, what is a CC? Critical characteristic, safety characteristic. These are things that affect typically steering, braking, fueling systems, high energy systems, passive safety. These are things like seatbelts, airbags. If they go wrong, they can kill someone or they don't work. Tight tolerance is another point. So if you've got something which really requires a precise and tight tolerance, like machining typically, or it's a sensitive component, again, you need to make sure your MSA is absolutely spot on and needs to be good. And then CSRs is the customer specific requirement. Every customer is different. Everyone has got their own little pocket of knowledge, which is different from each other. You might find that the German approach is very strict, but it doesn't necessarily do the right thing. Gauge R&R in itself has its own flaws within its manual. Everyone is different. You need to do more than one study to have a really good degree of confidence.
Yeah. Okay. So when MSA fails the customer? Chris?
Yeah, when does it fail us as a customer? Well, it fails it when it's performed in the wrong range. You're not measuring the real values. It's an extended range, or it's too short of a range. So if you've got a tolerance of plus or minus 10 millimeters and you only decide to do that study with not enough distinct categories in the range, then it's a fake way of doing it. It's false.
Let me display here the comment which showed up from Hamilton.
Yeah.
Thank you, Hamilton. You remembered about this. Very nice. Great. Okay.
Just as I said it as well, it's important to understand that you need to know
Yes.
the range of the tolerance in and out.
The
Operators
parts must vary. Yes.
Yes, they need to vary. They can't be nominal. They can't be just slightly above or below nominal. They need to be at the full specification range within at least 5 NDCs, non-distinct categories minimum. Again, I'm not going to go into the detail of it. If you want to learn more about it and you think, what the hell is that and how do I know? Please reach out. We do have training courses on that, and I'm more than happy to explain with real world examples how to do that. Point 2 is that operators trained for study, not reality. So they don't understand the variation. It's very theoretical. It's very classroom. You know, operator input is very important in the MSA. You know, if they feedback and go, this gauge is very hard to use, then already they're telling you, you're not going to have a good result. There's no point of doing the result if you know that you don't meet certain criteria in the first place. Failure 3 is no monitoring of long-term stability. This is really important. So if you're looking at the very short-term process potential, CPK, it doesn't mean over time in different groupings, in different sample sizing. And I see this on LinkedIn a lot, and there's some really good consultants as well that make some comments about stability and grouping. If you pick the first 25 parts and you don't then check different batches afterwards, you're not really understanding your true process stability. It's very batch to batch. And CPCPK and even PPPPK is assuming everything is dead centered on the process average or mean. It will drift, and the Six Sigma people will say you should work to your 1.5 Six Sigma drift. That's utopia. Very difficult to do that if you don't control your process. Let's talk about the next point, Agatha. I'll leave this to you, actually, if you want to add to it. Yeah.
Yes, of course. So no control plan reaction. Definitely a kind reminder for everyone. All the measuring methods with measuring devices indicated in the control plan must have MSA study. Yes. The only exception is that if you have the family of the measuring devices based on a certain criteria, like maybe the same resolution or the range, then you can group it as a family, and you don't need to check 10 calipers. You can check only one representant. Yes. But the only thing is that you need to remember everything what is in control plan must have MSA. Don't forget about alternative control methods, because this is also important. And you also need to have MSA for them. Okay. Chris, anything you would like to add?
I think that's a really good point about control plan reaction. I've worked with suppliers where they've had gauge wear, for example. So over time they use pin gauges. These pin gauges are cutting into an aluminium material. So they haven't provisioned for wear and tear or friction, which is natural. You will get that unless you use laser gauges, light optical devices to do this. So the old school method is to use something called a pin gauge, which is a cylinder. It's made out of hardened tool steel. It's ground down to precise values. And what they did was they welded it up. They welded up the gauge, added a material, and it changed the result. And then the MSA changed, but they didn't re-perform the MSA and they didn't inform the customer. So there are some real world examples where this happens more often than not. And it's about trust and confidence.
Okay. So let's shift into SPC a little bit, okay? Let's go out from MSA. Chris, comment this, please.
Right. So what does this mean? SPC, an equal symbol with a line through it, CPK. For those who don't know what that symbol means mathematically, it does not equal. That's what it means. SPC does not equal CPK. What SPC really is looking at the process behavior over time, a time interval. And if you were to say, well, I could do it by samples, it's the same thing. Your samples are not made exactly at the same time. They're made in sequence. So that's what we're measuring. The same, you know, when a CPK perspective is talking about a comparison to a specification, your upper and lower control limits, and within a certain number of standard deviations. We're looking at the normal distribution or standard distribution or a bell curve to see where does most of the data sit. That's what it does. Let's talk about it. Sequence matters. Stability is first, must be first. Your machine needs to be stable. If your machine settings are not stable and the maintenance is bad and it's not controlled, you're wasting your time. The next thing is statistical control. Are you looking at it from that perspective? Once you've achieved stability, are you looking at your indices? Are you looking at your range charts, your different charts to understand, is the process stable and how is it behaving? There's many rules. There's different statistical rules saying if you're 7 above or whatever, or a certain amount below, technically you're not in control. It's not stable. So you have to look at those rules of thumb and sort of process best practice. Capability. Capability is two sides of it. One is talking about potential capability, CP/CPK, and then PP/PPK is over time, as I've mentioned.
Okay. So now I think a lot of people is waiting for this.
Yeah. A lot of you are probably thinking, right, I've seen that yellow book, seen it on LinkedIn a lot, seen a lot of people copy it and paste it. What does this mean? What does it mean? So I've attended some really good reviews by some AIG people, and there's some really good key takeaways. One of the key things that is being defined in the new edition, again, there are some caveats that I'm going to say at the end. The observations are that there's 6 quality control loops that are being defined. Could change. That's the disclaimer. But it's more like a APQP approach. You know, when you're looking at your pre-series, your prototyping, and you move through the phases, how do you get to that journey of stability before you can then declare that the system is correct and it does its job? The next point is clear requirements for applications. So again, machine capability, process potential capability. There's different areas and different scenarios where it should be applied. So it's not just saying this is the theoretical way of doing it. They're giving examples of how to do it, not just a random book, which is good. The capabilities index calculations, so the geometric method versus the Z factor method. If anyone's ever had to study SPC, and I've had to do that in the university application where you've got to do the Z tables and look at the different versions against degree of confidence and confidence intervals. It's comparing the two because the foundation of the standard distribution is based on Z tables. That's where it comes from. What's next? So the fourth takeaway from me, there's more than 4, is that preliminary process performance studies. So what this means is assess it before you really declare that it's definitely stable and it's in control. It's really understanding the process before you kick it off. Is there any adjustments? Is there any training that you need to do? Is there any special requirements? Is there any new jigs you need to put in place that are better and beyond? That's what that means as an interpretation. So as a disclaimer, let's talk about the disclaimer. Do not believe if anyone says that this is the 100% happening. Okay, this is just an observation. This is based on the review text, which is still under review. It can change. If anyone on LinkedIn or anyone in your circle says, I know that's what's going to happen, and they're going to sell you something, in our good consciences, quality-wise, please do not pay money for this because it's not released yet. Okay.
The same with ISO 9001, yes, which is
Right, yeah.
going to be released this autumn, and already a lot of courses are sold on LinkedIn. Strange thing. Okay.
Smoke and mirrors. People like to try and generate income, unfortunately.
Yeah.
Be careful. All right, let's talk about this, 𝐻𝐻𝐻𝐻.
Yes, I really need to add this last statement here. In IATF, we have continuous improvement point, just very last one, and has really important note, which as a note, in fact, is not a requirement, but it's really reasonable, and it must be emphasized also during our webinar, because you shouldn't start doing continuous improvement if your manufacturing processes are statistically not capable and stable, or when product characteristics are not predictable and do not meet customer requirements. These are the conditions where normally you shouldn't start continuous improvement, because otherwise you are doing coming back to the normal basis point, yes, but not doing something more for your processes. Yes, like develop them to enhance more effect results of those processes. Okay. And
I want to add something on that, actually,
yes,
which is
please.
a misconception. A lot of suppliers and OEMs, some of them mistakenly believe that continuous improvement is getting back to being in specification. That's not continuous improvement. You should have been in specification, is the point. So when you have a product or a process which is failing the intended performance, you're trying to reach improvement, not continuous improvement. Continuous improvement is about getting better, leaner, faster, better quality. That's the point of it. And there's definitely a misconception from the Kaizen approach that people think Kaizen is about improve everything, make a process back in specification. That's not what it means.
Yes. Okay. I unfortunately must say that this was the last slide, what we prepared for you today. But this is a good moment to answer your questions, if you have any, or to discuss still something, what you comment on the chat. Let us maybe have a look what we have as the questions. Maybe, yeah, there is one. Steering system noise can be considered as example to attribute agreement. Chris?
I actually love this one. It's a very interesting topic because I have dealt with many different commodities in my career, and one of them is steering systems like steering columns, steering racks, and so on. And there's a very subjective assessment where a customer says it's noisy. I don't like it. It's not fit for purpose. You'll hear that a lot from a customer. It's not okay. Actually, you can, by scientific methods, get past the whole attributive thing, which is subjective and having a limit of agreement, and you always have to keep leveling, which is very difficult. You can measure the hertz, you can measure the frequency, you can measure the waveform of the sound and the peak amplitude. So actually, it can be done using scientific principles if you have the drive and ambition to try and quantify it that way. It doesn't need to be a qualitative assessment, 0, 1s, pass, fails, go, no go is what you're getting to. You can quantify that through scientific methods. It is possible. If you want to learn more, reach out, please.
When you said about this, I thought about signal detection method, which I find it here to be applied. If we quantify, for instance, like you said, this parameters, and then to check by the appraisers. Okay. Oh, this is nice. What about the MSA for the vision system? Yes, vision systems, if I can tell you from my experience in electronics, for instance, they were performed as a procedure 3 because they were mostly in automated processes in electronics, yes, on the long machining, yes, stations. So there was no influence of the operator, yes, so only the repeatability was important. And then based on this, we were doing HR without influence of the different operators, yes. Chris?
Yeah, just to elaborate a little bit further than that. I mean, from a process engineering perspective, vision systems are affected usually by light sensitivity, so relativity of light.
Yes.
So your environment's very important. So it might work better in the
Contrast.
daytime. Contrast in the daytime is spot on. Night shift doesn't work, doesn't detect it, or it's giving you a false reading. So you have to be very careful with camera vision systems and how they work. Like anything, you need to have a Poka-yoke master samples, good and bad. Challenge it, prove it. It is a good technology. It can be reliable, provided you have a robust error proofing or mistake proofing challenging system to do that. This would be my view.
And we have also one interesting question. Anya really asked a really good question. What if I run sometimes tests in external lab and it's in my CP? Do I need MSA study? Chris?
Okay, well, it does depend on what is it you're measuring. So if we're talking about a hardness tester, right, that's a type 1. Okay, it's a defined science. it's Brunel or Vickers, or if it's show hardness, or we talk about rubber, it's a defined method. So again, provided that the external lab, which I would assume that they have a very highly skilled, trained metrologists, which is a lot better than people typically internally inside of an organization. The expectation is that they have procedures, they follow the procedures, and it's done in a controlled way through competency. So it's not a no. It depends on what you're asking them to measure. If I give them something like a back door and say, measure that, and give them the gauge, do they know how to measure it? Do they know the instructions? Are they trained? It depends on what you're asking them to measure. Yeah. That would be my answer to that.
Okay. What else do we have here? What are the most common mistakes companies make when implementing SPC or MSA? Well, I think we said a lot on the way, but I would start with this, that MSA is too late done. And we are starting SPC implementation without having MSA. Chris?
I think there's an obsession currently about AI, and well, not I think, I know. And I'm very old school in terms of hand calculations, really, manual charts. Of course, I believe in real-time data. I absolutely believe in things like Power BI, Click, whatever system you use to gather that data set is really important. And I've seen some excellent systems that have that. But the next thing is about AI. And my view is that the data is only as good as the validation of the data set. So you do have to be careful that everyone thinks that AI is going to fix everything. It doesn't replace quality professionals currently. It's still quite a subjective and in some cases an objective position. So there is an obsession at the moment with that. And they think suddenly because they use AI, it solves all the problems. I've seen that. That happens a lot.
I also add here as a maybe not mistake, but maybe a gap and missing competences, really.
Yeah.
This is really a hard competency to work with SPC and MSA. So we need to be trained, yes, to the level of the responsibilities we have to work with those two. Yes.
Yeah. What I would add as a master trainer, from my perspective, in this subject, training is important of how to do it correctly, but also observing when you're doing it wrong, because the training is important to know that the measurement, there's something wrong. Like, for example, if you fit a part into a gauge and that part is not seated correctly and you get a bad measurement result, you don't continue the measurement and think it's definitely the part that's wrong. You need to remove it, reassemble it, double check that there's not something wrong with the datum strategy. There could be damage. Stuff like that. I've found that measurements have been declared by suppliers when actually it's because someone damaged a part and fitted to a gauge anyway. That can happen.
Okay, let's maybe display last one because we are almost out of time. But yes, the next one. Please make more explain on this relation between MSA and control plan. Let's make the long story short. According to IATF requirements, you need to have the MSA done for all the devices, measuring devices, test equipment, which is indicated in the control plan. Okay, there is FIQ 6, which is stating that you can make the families of the measuring devices. So not only IATF itself is giving you some indication how to work together between these two, but also you may have this FIQ helpful, because if you are using, I don't know, 100 calipers in your organization, you may have only one MSA done for this caliper. Okay, Chris, I don't know, we are almost out of time, and we let's agree that if we will find the questions left on the chat, we will come back to you with the answers under your questions, okay? Because we value your time, especially here in Europe, when there is an evening already, and we don't want maybe to take more of your time, okay? So just at the end, let me remind you that if you would like to learn more from QualityWise, we invite you to visit on our website the resources tab, where you can find our blog, and the podcast episodes, and also this webinars, possibility to register to receive this presentation and additional materials, as I said at the very beginning. Also, please remember that we will meet in 1 month for the third in the row of these webinars, and next time we will talk about auditing on the shop floor. So definitely we will talk a little bit about ITF, LPAs, VDA 6.3 probably, because I believe this is one of the most widely applied auditing tool in automotive, especially for German market. So we'll talk also about VDA 6.3. Probably we won't have time to add here VDA 6.8, but we'll see. Okay, so please remember to join us in 1 month and register on our website with this QR code on the top left right corner to get your certificate of attendance and the materials from this webinar today. Okay, so let me thank you for your time, for being with us, and your valuable comments.
Thank you.
Thank you. Bye.